So, good day everyone. My name is Dan Roberto Mare from BS Packaging Engineering, and this is my lesson number 3 for um, techniques of integration. So, first, let's review U substitution. So, U substitution is um, substituting the harder part of the integration or the function um, by U um, for you to have an easier time integrating. So, example 1, derivative of 2x squared minus 9 for dx. So, how could we integrate that? So, I'll use this x squared minus 9 as my u. So, we'll have u equals x squared minus 9. So, let's find du. So, du is, we'll just multiply it with d over dx. So, du is equals to, what's the derivative of u? Is 2x. So, um, yeah, du dx should be du dx. So our dx is equals to substitute 2 or swap places, swap their places. So you'll have du over 2x. So you'll have, it's now can integrate. So 2x, so it remains because the x squared minus 1 at 9 is the only thing that we substitute. So 2x, this will become u 4, and our dx is equals to d over 2x. So what will happen? We can cancel 2x. So you'll have u 4 u. So go ahead and integrate. So u. Let's 4. It's 4 plus 1. So we already know this. So let's just have u 5 over 5 du. So we'll have the answer. So substitute back x squared minus 9. So x squared minus 9 close. So we have 5 here. So let's put 5 over 5. So add your constant receipt. So that is our answer. So next, let's see if we have space here. So let's try. Just a review. So number 2. So we'll have 4x squared minus 1 by 7. And we'll have x here, dx. So we already know that 4x squared minus 1 is much harder to integrate than x. So what we'll have here is u. U is equals to what? 4x squared minus 1. So du equals 4 times 2 is equals to 8x. So dx. So um, our du is, yeah, that's all we need, I think. So our dx is equals to du 8x. So let's integrate. Hope you have space here, so let's integrate. So what we'll have here is, we'll have u7. So we'll have x and times du over 8x. So in this case, you can just cancel here, cancel this x. So you're left with u7 du over 8. So what we'll do with the 8 du over 8. So we can simply put or interchange like this. So the denominator 8, just put 1 8. Put it out of the derivative u7 u. So in this case, what we'll do, 1/8. So when we integrate u7, will become u8 plus 1 is plus 1 here over 7 plus 1. So over 8 du. So the du will be terminated. So we just plus c. And supposedly there's no antiderivative here. So let's have 1/8 times what is our 1/8 tapos what we did here on the other side that we took out, oh I mean here we took out 8, so we can also do this here. So this 1/8 times 1/8 is the 1/8, so plus u, so or times u 8 plus c. So in this case, when you have this, you can substitute. So substitute. So for a sec, I'll just get my cat here because he is very annoying. Say hello to my vlog. Hello. Hello. Okay, dito ka kay kasabad si mo. Ato na eh. Shoo, 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 shoo. Okay, going back. So what we're gonna do here, so multiply. We'll have 1 over 8 times 8 is equals 64. And what is u for x squared? 1, 8 plus c, a constant. So in this case, we don't have anything or something to simplify, so this is our final answer. Okay, we're done with u substitution. So let's just head over to the next lesson. So integration by parts. So let's review it another one. So remember that we have Lie8. So what is logarithms? Inverse trigo. A is algebra. And trigo. And exponent. So number one here, we have ln x dx. So the formula here is derivative of u du equals uv u dvm uv minus v du. So x. So our u, what do you have there? So let me see. The priority of u, this is the logarithms, inverse trigo, algebra, trigo, and exponent. So in this order, we'll choose what our u will be. So in this order, we have logarithms first, inverse trigo, algebra, trigo, and exponent. So in our function here, we have an algebra and a logarithm. So logarithm is first, or comes first before algebra. So you'll have ln x. So du is equals, this is our du. So du is, ln is just 1 over x. So v is equals x. That's our x. V is our second priority here, so du dv is equals 1. Let's just put the x here to indicate that the dv is from v. So you have ln x here dv. So ln x times x minus what? uv. Just multiply the both. So you have v. So what is our v? V is x. So when we have v x and our du, what is our du? So our du is, this is, I'll just indicate this u. So our du is 1 over x. So let's simplify. We'll have dx here. So x ln x minus what we have here. So in this case, you can just cross this out. So you'll have integral of 1 dx. So This is copy here and x. What is the integral of 1? What will it become? So it becomes just x, negative x, because minus. So never forget your constant. So my cat is sleeping and he wants to sleep. So it's 11 p.m. here, so that's why he's waiting for me. Now that's our answer. Number 2. We have 2x ex dx. So in this, it's fairly simple, but it's just a review. I'll just explaining or reviewing our last lessons. So your u, what is our priority? So first, logarithms, inverse trigo, algebra, trigo, and exponent. So what we have here? We have here is an algebra and an exponent. So our u, so algebra comes first before exponent. So it's just 2x. And our v is equals to what? Ex. So our du, the derivative of u is 2. And let's just indicate it with dx. So we will know that this is the derivative of u. So dv is still ex. But let's just put dx to know that it's derived from v. So what we'll have? 2x. So let's derive 2x. So 2x. Let's just, I'm sorry, this is wrong. So let's cross it out. I'm sorry. So let's just do it again. So uv. What is uv? u is 2x multiplied by ex minus the integral of what? Integral of ex times du. So ex and du. So the du is equals to 2 to dx. So this put x. So what we'll have here is 2x ex minus, yeah, negative ex plus c, your constant. So um, that's it. That's how easy it is. So answer. So that is our integration by parts. So I'll just explain the basics here. So another one. This aside. So next we have is, what do we have here? Let's see. Um, Integration by trigonometric substitution. So integration by trigo substitution. Please excuse my handwriting. So first, so the rules of in trigo substitution, we will have square root a squared minus x squared is equivalent to x is equals to a sine theta. Number 2 is um, number 2 is um, a squared plus x squared. So when you plus, you'll have x is equals to a tangent 0. So number 3 is, I'll just pan it closer to my hands. So okay, number 3 is what? When you have integral of u2 minus a squared equals x, should be x equals to a secant theta. So that's our basic rules, are our basis in integration by trigo substitution. So example. So let's have an example here. The one we'll have dx. It's a constant here. It's x squared square root of 4 plus x squared. So what we're gonna do here, um, what we have here is, let's find our variables first. So we'll have, so you can see here it is x squared. So it is a squared plus x squared equals to x equals what x is, because it's a squared plus x squared. We have a is equals to a tangent theta. So a is equal, a squared is equals to 4 and a is equals to 2. And let's see here, our x uh, our x is equal to 2 tangent theta, and our dx is equals to um, our tangents excuse me. So derivative of 2x tangent is secant secant squared, 2 secant squared theta d theta. Or x squared is equals to 4 tangent squared theta. So if you ask me, why do we have x squared here, it's what is all about, what it's all about. So our x squared is because we have square root, so square root. So we'll have x squared, so we can terminate the square root. So we have to have, so 2 secant squared theta d theta over what? Tangent squared, and tangent squared theta secant squared theta. Oh wait, I think I'm wrong here. I have my notes here on my side, so it's wrong. So what we should have here is the x squared. So what we should have here is, from this, x squared should be 4 tangent squared. So I'll just put here 4 over 4 tan squared theta multiplied by 4x. So square of, oh no, um, square of 4. So I'll just copy this 4 plus x squared. So we can't just put x squared there, we should put the value of x. So x squared is 4 tangent squared theta. So what's next? So let's take 2. So 1 half. Let's take 2 on the other side. So we have secant squared theta d theta over um, when I took 2, it corresponds with 4 as a denominator, so we'll have 1 half, which I should have write this as 2 over 4 first, because if you cover this, you'll just have 2 over 4. So that's where our 1 half came from. So we'll have tangent squared theta and square root. So for tangent squared. So in here, we can do something different here. So We can transform this as actually, because it's tan squared, right, actually you can put this as this. So you'll have 4. It's almost like or it's really like it's is um factoring. So got 4. So you have 4 here. So let's have 1 plus, see what we have, 4 and this one. So tangent square theta. So if we multiply, 4 times 1 is 4 plus 4 tangent squared. So we'll have here is 1/4, 1/4. So 1/4 secant squared theta d of theta and tangent squared theta. So what will happen here? So um, this would become, so it will become secant squared theta, so equals to 1/4 um, secant theta d of theta squared. Forgot the squared. So actually we um can actually cancel out something here. So wait, let me think first. I'll put this squared, squared. Can actually cancel the 2 here, right here. So we shouldn't have 2 here. So for the second theta d of theta. So in this case, can just we cancel this out to this. We'll have, actually you can cancel second squared, um 2 second squared, but we only did cancel the exponent 2 because it has square root. So you're left with 10 squared theta. So what we could do here, in this case we can't really integrate this, so what we will do is, I think we can do reciprocal here. So let's have 1/4. So reciprocal of second squared theta d theta, d of theta is second d4 theta. You'll have 1 over cosine sin theta. Am I right? Yeah, I'm right. I'm right. Times the reciprocal of tangent. So reciprocal of tangent is cosine 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 theta sine square theta. So what could we have here? So I think I have squared here. Okay, okay, okay. So we have 1/4 and it will become 1 over sine theta times cosine theta over sine theta. theta. Deal with theta here. So what would we have here? I'm not really sure. Wait. Okay, I think we'll have here is I think we'll have here is 1/4. So I think in this case we still can transform this into something much more easier because having fractions is such a pain when integrating. So 1 over sine theta is cosecant theta times cotangent. This would be cotangent theta theta. So let's recall. So our antiderivative formula. So what we'll have here is 1/4 negative cosecant theta plus c. Okay. So cosecant plus c. Is it right? Yeah, that's right. So we'll have 1/4 cosecant theta plus c. So let's plot here. So our basic, so our triangle applicable here. It's applicable here. So let's have excuse me. So x equals to tangent theta x over 2 is equals to tangent theta. So let's have our triangle here. Theta is right angle. So, our hypotenuse here should be this 4 plus x squared. So squared 4 plus x squared. Then our basis should be 2. And this is x. Yeah, that's x. So I'll have here. So you can recall that sine theta equals to opposite over height, and cosecant is the height over opposite. So what we'll have here is cosecant hypotenuse over opposite. Opposite is x. So we'll have for hypotenuse 4 so it's negative cosecant. So plus x squared plus over n. So over 4x plus c. I think so. If you ask me why this has 4x, because of 1/4. So we put 1/4 below, so we'll have 4x. This one here. So this is our final answer. I'm not really sure if it is negative here or not, but let's take it as a negative. see. Alright, so let's have another one. So, next lesson. So, partial fractions. Oops. So, I will have partial fractions. So, what is a partial fraction? So, partial fraction is a technique used to reduce a rational function sa equivalent sums of rational functions. So sa first case, we'll have the first case. Case 1. So the formula we're gonna tackle is 9n, I mean x minus a, x minus b, and x plus c. So in that case, we'll have a, so x minus 2, a and b, plus b, x minus b, plus c, x plus c. So in the first case, we're gonna use this formula, and so case 1 is called reducible factors. Reducible factors. So how could we use this? So let's have an example. So first, let's have an example. We'll have, number 1 is 3x over x squared minus 16. So what we'll have here. So in this case, so it's called reducible factors because most of the time you'll just factor the denominator or the mostly denominator. So basic factoring, x squared minus 16, so it is a minus. So when you have minus, so it is should be, we'll have 3x here. It is positive and negative. So to have x squared, simply x, to x's. So we'll have what next? 16. So what are the factors of 16? So I think the easiest is 4 because square of 4 because it's a perfect square. So we'll have 4. I think right there we have our factored function now. So x is 4. So what we'll have here is a. Let's put integral. So a over x plus 4 dx plus b x minus 4 dx. So in this case, we'll have to find the values of a and b. So we'll have the cum cover up method. So in this lesson, I'll be covering some methods here using impartial fractions. So using cum, we'll have a and b. So to have, these are n, 3x. The first term is what? X plus 4. And the second is x minus 4. Okay, what do we have here? So to become to I mean to make the denominator 0 or undefined, you should have the x should be equal to 0 here. So x is equals to 4 and x is equals to here negative 4. So with negative 4, we'll just treat it 4 over 4 plus 4. What we'll have here, 3 times 4 is 12 over 8. So, or you can put this at 1.5. Here is 3 times negative 4 over negative 4 equals to 1. So we have negative 4 here on B because when you go to A, when you replace this x to A, it will become 0 here. Same as here. If this 4 is mixed with this 4 as x here, we'll have 0 also. We'll have negative, positive here and below, positive above, so we'll have negative 12 over 8. So it's equals to negative 1.5. So we have our two um, values here. So let's use these values because it's much easier. Let's just substitute the a and b. So we'll have a. So a first. So integral of what is our a? 12 over 8. 12 over 18. 8. 12 over 8 over x plus 4. So dx plus what will plus here? So plus here is the b. So the b is what? Negative 12 eighths over x minus 4 dx. So when you have we know that this x plus 4 as a new denominator is simply ln. So what is our we need another one. So we have here is ln. So simplify. To derive it, simply have 12 over 8 ln. ln of what? X plus 4. It is should not be negative. So plus 12 over 8 ln. What is the denominator? X minus 4. So other constant. So right here, you can really say that this is our answer, and you can combine these two. So that is our answer. So let me get another bond paper. Next, let's have another case. So second case. Case 2. That's our case 2. Have n squared. So partial fraction, it has repeated linear factors. So put linear factors in the denominator. So repeated linear is x minus 1. So as an example, we'll have ax plus b x squared plus c x minus 1 plus d over x minus 1 squared plus c x minus 1 cube. So that is our formula, these are bases. So we'll have an example. Example is 3x squared minus x minus 3 over what? X squared x plus 1. So what we'll have here. So let's see. So we'll apply this. So how much we can do? So it's also equals a x plus b x squared plus c x plus 1. So in this case, um, what we can do is um, this technique is um, one of the most common techniques used as far as I can see from the internet. So use this one. So if do you have a clue what you can do here? So this is a factor for this. So what we do? Use this, multiply. So let's multiply this by x squared, x plus 1. Same as here. Oops. Can multiply here by x squared, x plus 1. So in this case, you can cancel this out. You can cancel this x, cancel x squared, cancel x plus 1. So we're left with 3x squared plus minus x plus 3. So what we'll have here is, we'll have ax, x plus 1, and b, x plus 1, plus c, x squared. So let's multiply ax. So times x is a is our numerical coefficient. It's not um, a variable, so we'll have ax squared plus 1. So let's just disregard the 1 in that sense. So ax. So I mean is ax times 1 is still ax. We'll just put ax here plus bx plus I did this for your um, for clarity. So have bx plus b plus, just copy, cx squared. So we'll have combine like terms. What is our like terms here? Um, let's see x bx. Oh, I don't think. No, I don't think so. Let's not combine the like terms. I think combining like terms will be wrong. So we'll have ax. Let's just rearrange this. X squared plus cx squared plus ax plus bx plus b. So we have to equal this to r, because we multiplied here, right? So we equal this one to our numerator. So 3x squared minus x minus 5 is equals to what? Can we write this as a plus c? Let's factor this one first. So a plus c multiplied by x squared is equals to these two. So we have 2 plus. So ax bx is just simply a plus b multiplied by what? X. So plus b. The numerical coefficient of 1. Sorry, I hit my. I just hit my camera. Okay. So right now, what we're gonna do here? So what we're gonna do here is adjust this first. Okay. So we have here. Okay. So in this case, let's find the value of a plus c. Plus c is equals what? C equals 3. Plus b is equals to is equals what is that? negative 3 is equals to, so a plus 3, that's negative 1. So plus b negative 1. So in this case, you can't just put values in the other side. Uh, you can, but well, you have the same answer. It's kind of boring if you just put negative 3 as positive here and just will have positive 2. But you can have this kind of 3 plus 3. So what will have? A cancel this 2 plus what? 2. And 2 plus c equals 3. So um, negative 2, negative 2. So c equals 1. So what we have? So what is our next move here? So we'll have a is equals, so we'll have the a value, right? Wait, I think the camera got so much closer. Let's, right there. Okay, so we have our values now. So we didn't find b because it's no need, we already have b, so it's negative 3. So what we'll have here is substitute this one, ax bx squared, so x minus 1. So 3 values a over x and b. So I'll disregard this. So a value, we already have a value, so 2 over x minus the value of b is equals to, or I mean is, yeah, the value of b, we have negative here, 3 over x squared, so plus c, x minus 1, plus what we have, c is 1 over x minus 1. So that is our answer. Okay, it's already dirty, so let's just substitute our paper. So what do we have next here? Case 3. So what is our case 3? Case 3 is about quadratic problems, so quadratic functions. So what do we do with quadratic? So n over ax squared plus bx. Let's see, so given formula, so a times 2a plus b, I mean, ax squared plus bx plus c plus b over ax squared plus bx plus c. So this is our basis or formula, like as what we did from our last cases from partial functions. So what we will have here is, so another example, 3. Stick with 3 again. So x minus 1, let's do x minus 1, x squared plus 2. So we'll use the same technique as we did in the second part. So is equals to a x minus 1 plus b, x plus c over what? X squared plus 2 plus, so let's just enclose this, or because what we're gonna do here is multiply this. So multiply this by x minus 1, x squared plus 2. Alright. Also, this one is multiplied by x1, x minus 1, I mean, x squared plus 2. Same here. X minus 1, x squared plus 2. X squared plus 2. So, right here, what we're gonna do here? So, here, this is cancelled. In this case, x plus 1 is the only thing that you can cancel. And you have x squared left. And here, we'll cancel this one. You're left with x minus 1. So, this is equal to what? We'll have 3. So, we'll have 3 left with a times x squared plus 2 plus bx plus c times x minus 1. So, we slightly simplified this equation to this by just multiplying them to the denominator. So, you'll have, so what we're gonna do, simplify again. Have ax squared plus 2a, okay, this one, plus what? Bx times x is bx squared, and plus cx. So let's follow this first. Minus 1 times bx is bx is negative, because of the negative 1, plus c times negative 1 is negative c. So in this case, you'll have ax squared, let's just rearrange, plus bx squared plus, or I mean minus bx plus cx plus 2a. We'll have 2a here plus c, or I mean minus c. So okay, let's do something different here. Someone is messaging me, I'll just disregard that for now. So I'll have, so right here it's just only 3, so let's just put 0x squared plus 0x plus 3. So just so we can simplify it more. So a plus b x squared plus negative b plus c plus 2a minus c. So in this case, let's find a plus b. A plus b is equals to 0 because of the x squared. Negative b plus c is equals to what? 0. 2a minus c. So 2a minus c is 3. We'll have x here, I'm sorry. But still it is 0. It has no value because of the numerical coefficient of 0 is of x is equals to 0. So you'll have both zeros here. So this term is the term. So 2a plus c is equals to what? So a plus b is equals to 0, and 2a minus b is equals to 3. So what we will do here, so 3a minus b and 2a equals 3. So we'll have 3a is equals to 3, a is equals to 1. So 1 plus b equals 0. Now to have 0, you'll need negative 1 plus b. Next is c. Negative 1 plus c is equals to 0. So what do you have c? So we'll have this here is two negatives here, minus negative, so it automatically is 1 plus c is equals 0. So it's negative 1. So we'll have the terms here. Let's just substitute it here. So what can I do? It's equals to 1 over x plus 1. So here we have here x plus 1. So what is our b? b is negative 1 plus negative 1, or it's not, um, I think it's, let's just take away this plus sign here because it's unnecessary. We'll have negative 1x here, so 1x, because we have bx here, right? Bx plus c. So we have the value of c, we have the value of b, so we have 1x minus c. So it is both negative 1, so c is should be negative 1 here. Sorry. So we'll have x minus 1, x squared plus 2. So it's equals to what? So our answer is 1 over x minus 1 minus. So what we did here is this one, 1x 1x. So it's not very important to, or it's not very necessary to just put 1x. Let's just consider it as x plus 1 over x squared plus 2. So it's given that it has 1 here and 1 as coefficient, as numerical coefficient if we don't have it given. So that is our answer for case number 3. So let's go to our next lesson. So this lesson is quite hard, or in Ilonggo term is UTI. So we have double and triple integrals. So double and triple integrals is usually will have two integral signs or two antiderivative signs, and two in double. So we have two integral signs and two um, upper limits and lower limits. So you'll have um, first, so you are respecting the x and the y axis. So for your constants, you'll have dy and dx at the end. So when it comes to triple integral, it has the same concept that it has, but in triple integral, you'll have 3 rather than 2. So example, so integral sign limit 1, 0, another integral sign x 0, integral sign another limits. In that case, from the x and y, we have dy and dx in double integral. Now in triple integral, we'll have dx, dy, and dz. So first, let's have double integrals. So double integrals we'll have here 2, 0. So another, because it double integrals, so 3, 1. So let's have here a little simple. So xy squared. So this is our function. If you ask, what do we lack here? So we have x and y. So respectively, we will have dy and dx. So first, let's focus here. So in this case, you can just integrate it as is. But it's called double integral because to separate it into two. First, I'll use this and dy. So this is my first step here. So later, we'll have integral upper limit of 2, lower limit 0, and dx. So we can solve that later. So we'll have, so first, let's just focus in here. Just focus there. So you'll have, what is that? 3, 1, xy squared dy. So in that case, we can now integrate this. So xy, so 2 plus 1 is 3 over 3. And limit of y equals 3 and y equals 1. So we'll have x over 3. Let's have x over 3. So we'll have here the both of the limits. 3 cubed minus 1 cubed. So what do we have? Oh, I'm sorry. I think, yeah, yes. We'll have x here because we're finding for the y. So negative 1, so it's still x over 3. What is 3 cubed? 3 cubed is 27 minus 1. So we'll have, our answer is 26 over 3x. Okay, so I'll just simplify it and divide it here. So we'll have uh, so we'll have 26 3x. So next, um, because you already did this middle part, you can actually put now. So what is this part? It is 26 over 3x dx. Yeah, that's it. So in this case, we can now integrate. So let's put aside the 3 here. So let's just put a finger in the x. So 26 over 3 times. So we're now integrating. So x. So x plus 1 should be x squared. So x squared over 2. With respect to our limits, which is 2 and 0. So we can substitute now, but it is better to reduce it. So this could be, so you can cross multiply. So we'll have 2 divided 13, so is 2 divided by 26 divided by 2 is 13. 3. Still the same. Just multiply it by x squared. So let's terminate this and reduce it in half. So we'll have 13 6. So still your limits are 2 and 0. So right there. In this case, we can now substitute. So the same I did above. I just put it in denominator form and multiplied by your limits squared because x squared. So 2, 2 minus 0, 2. So in this case, let's just disregard 0 because um, 0 in any is just always 0, and in any power or exponent is just still 0. And the 2 squared here is equals to 4, so you'll have 13 over 3 times 4. So times 4, get your calculator to simplify. 13 over 3 3 times, sorry, it's not focusing, 3x, I'm sorry, I wrote 3x times 4. I'll just input that. We'll have 52 over 3. Over 3. So our answer is 52 over 3. So what is the another value of 52 over 3? 17 or 17 or 33. So that is our answer. So next, we'll just use the backside. I don't think we can fit the backside. Let's just take another bond paper here. So triple integrals. So when dealing with triple integrals, it's just the same rule as double integrals. You'll have quadruple, quintuple, or any pool or swimming pool, anything you want. It's just the way or order you're gonna put it or derive it. Just from the middle to outside. So let's have here. Example is 3, 0 again. So x 0, another 1 because it's triple integral. So we'll have x minus y 0. Let's just have 4xy dz. So and when dealing with triple integrals, we have x, y axis. So we'll have the two-dimensional. So in dealing with another, so in dealing with another axis, you'll have z. So your function is now in 3 dimensions. So dz, dy, and dx. We put dz inside our, as you can see that our x is primarily on the farthest because we start from the middle. So integral, you can just first do this, and if you have the value of this, you can substitute and do this one, and if you have the final answers of these two, you'll just derive it by that. So visually, that is how we derive triple integrals. So next, what we're gonna do here. So I'll just put this first. Let's just isolate this first. So first, so x minus y 0. So we have 4xy dz. So what we're gonna do here. So we'll have 4xy times z. So we'll have z is equals to x minus y, and z is equals to 0. So let's just change or substitute the fact the I mean the value of z here. So it's just 4xy. So x minus y, and your 0 0. So you'll have the answer 4x squared y minus 4xy squared, because we're simply multiplying. So we don't have a third term here because third term is just 0, just disregard it. So you'll have your value of this. So you can go ahead and substitute it. So let's deal with this right now. Yeah, see? So we'll have the limit of x in 0. So what is the value of this? It's now 4x. So 4x squared y minus 4x y squared. This one. So in this case, we'll have dy here, dy. So we'll end up having what? Having x0. So so okay, I'm wrong. Let's just let's not rewrite it. So just integrate it right now. So hey, integrate for x for so have for x squared. So y. So our y we integrate first our y and then our x. I mean we are dealing with dy here. So let's integrate our y. So y will have 2. Basic integration 2 and minus 4x. Because we're not first here, I forgot to say that in the um, first degree of integrating here, we dealt with z or our z value. So after we dealt that, we had left 4x squared y minus 4x y squared, and that is we have um, um, two remaining degrees of integrating. I mean is we have 2 degrees left to integrate, which is x and y. So right now in the second degree, you'll will be dealing on the y, which is our second degree. So y squared is 3 plus 1 plus 1 here. So I have 3 over 3. So now what we're gonna do here. So sorry, I forgot to put y equals x and y is equal to 0. So we'll have here is we're combining what? So you'll have 2x, I think 2x squared. Um, x squared, another x squared minus 4 over 3 x cubed. So minus 0. And I think we'll combine that. So we'll combine these two. So 2x to the fourth minus 4 thirds. This is 4. So 4 thirds. And x. So multiply this one. 4. So let's combine the same term here. So 4x. 4. Combining the same terms, you'll have what? You have 6 over 3. 3 x 4 minus 4 x 4. So we have now our answer is 2 thirds x4. So simplify it. So our third degree is now we're dealing here. There we have the value of these two. So right now we'll do it. So 3 and 0. 2 thirds x4 dx. Now we're dealing with x. So we're now integrating x. So we'll have our final answer after. So 2 thirds and x4. What happens to the x4? It becomes 5 over 5. We have 5. So with respect to 3, 0. So it's equals to. So cross multiply. 2 over 15. So on x5, we'll have the values. So x is equals to 3, 5, and 0. Okay. So in this case, what we're gonna do here is we'll retain the 2 over 15, and the 3, we'll just disregard this because it's useless to put your time into that because it's just 0. So 3 over 5. So I am not a human calculator, so I'll use 1. So 3, 5 is equals to what? 243. 243. So um, this could be our answer, but I'll still simplify it. 243. We have our 243 here multiplied by 2 over 15. It's equal to what? 32.4, or 162 over 5, or 32.4. So that is our final answer. So recap: in triple integrals and double integrals. Um, in double integrals, usually um, do we usually do x and y. Um, you'll have just two dimensions, x and y. We first deal from the middle to outside. So usually deal with y first before dealing with dx. So like this, the paper. So first from the middle, outside. Okay. So it goes with triple integral, but in triple integral, um, you'll have to do is um, what you have to do in triple integral is um, still from the middle to outside, but first you'll deal with dz, next is dy and dx. So you'll find the value of the middle ones first and go outside. So that's it for my lesson in masterclass number 3. And again, I'm the Nerd White Tumalay, and thank you for watching and listening.